All right. What would happen if you try the nth term test here? Let your limit as n goes to infinity. Hope that it's not 0. But it's going to be 0 because you're going to get infinity over infinity. And when you do L'Hopital, first time through, the top's going to become a 1. And the denominator is going to be like a product rule and all this stuff. But it's going to have n's down there. And so when you take the limit again, you're going to get basically 1 over 0. It's going to go to, 1 over infinity, it's going to go to 0. So no go. Is it geometric? Kind of, right? Do y'all see right here the 4 to the n? That's kind of geometric, but it's mixed up with this other thing, isn't it? N minus 1 over n? I mean, you could almost look at this like this. You could almost say that this looks like n, oops. N minus 1 over n times 1/4 to the n. Yeah? That's the same thing? 1/4 to the n, that's geometric. But with geometric, remember the formula is a r to the n, right? The n is only up here. This a in front is not a function of n. It's a constant. And the thing that's in front here is not a constant. It's changing, right? It changes as n changes, that changes. So it's not geometric. But hey, comparison, if I compare later, I might consider comparing it to a geometric, right? Because it has elements of geometric in it. All right. Integral test. I don't feel like integrating this. Telescopic, P-series, harmonic, nothing, right? So let's go straight to the comparison. And what would you like to compare it to? I've kind of given this away already. You want to go with the geometric? I'm going to compare it to 1 over 4 to the n. Right, 1 over 4 to the n, which is the same as that. That is a geometric series. Now, do I have it written in the form that we like to write geometric series in? No, it doesn't have n minus 1, right? But that's okay, because I could do that if I wanted to know what that converges to. But I don't want to know what it converges to. I just want to know whether or not it converges. And it does, right? This is geometric. And r is 1/4, which is less than 1. So I'm in business, right? All right. Oh, what does it do? Converge, right? Converges. What do we want to show? A sub n is less than or equal to b sub n. Oh, I forgot to check something. What did I forget to check? This is my a sub n, right? This is my b sub n. What do I have to check if I'm going to use comparison? Are these bigger than 0? Are they? This one is, right? Give me an n. This is always a positive number. Is this always positive? Not at 1, right? At n is 1, this is not positive. It's 0. But for the comparison test, you just need that those inequalities hold eventually. So it could happen that this is, less than 0 or something, maybe the first 3 or 4 terms, but then eventually it's bigger than 0. So we're still in business on this, all right? So we got that, and you said we wanted to show that the inequality a sub n must be less than or equal to b sub n. And so I want to show that n minus 1 over n times 4 to the n is less than or equal to, how about I write 1 over 4 to the n instead of 1/4 to the n. Oh, this is going to be so nice, isn't it? These cancel out, 4 to the n. right? Cancel. Gone, gone. And what am I left with? N minus 1 over n less than or equal to 1. Multiply both sides by n. Subtract n on both sides. Is that true? Yes. Therefore, that converges. Pretty nice, pretty nice. So the conclusion is that the original series converges. All right, let's do another one. Okay, that looks different, doesn't it? That's a little different than anything we've done up to this point. Yeah? Let's do the nth term test. Limit n goes to infinity. I'm hoping for something other than 0. Sine of 1 over n. Well, 1 over n goes to 0, right? And sine of 0 heads to 0. So that's not good, right? All right. Not geometric. Harmonic. What's inside is harmonic, right? But you're taking sine of it, and it doesn't transfer that way. You can't say, well, if the inside is harmonic, then the whole thing becomes harmonic. No. Because it's inside of a trig function, I'm not going to get that lucky. So it can't be harmonic. Integral test, you feel like integrating that? Could you integrate that? That might be a tough integral because of the 1 over n inside. That'd be a tough integral. Telescopic, how would you, what? I would have to start working on it. If you were just asking me, like you pull me off on the side of the street and I don't know who you are, you ask me how to integrate that, and I would tell you I'd turn it into its power series and integrate it term by term. That's how I would do it. But we haven't covered that yet. But if you wanted me to do it like old school style, like integration by parts or something, I would give it a shot, but I don't feel good about it. I don't see it. I don't see it right away. All right, so yeah, we got some problems. All right, how about comparison? What are you going to compare it to? 1 over n? Why? Because you see 1 over n? That's actually what you're going to use. All right? So you look, at some point, you sometimes just need to take a shot. All right? Now, this time I'm going to intentionally not forget that very subtle part. We have to make sure that these pieces are bigger than 0, right? And in my 9 a.m. class earlier today, I don't want to say I made a mistake. I didn't make a mistake, but I said, look, sine oscillates, right? Sine oscillates. And so if I do 1 over n, it should oscillate. But the fact is, if you were to try and graph sine of 1 over n, what's happening in here is it's headed towards 0, right? So if I graph this function, it basically looks like a sine curve that's headed towards 0. So here's sine. What happens is I head towards 0. It goes to 0, right? The question is, am I coming in from this side or this side? So are the things that are being plugged into that sine function positive or negative? They're positive, right? N is 1, that's 1. N is 2, that's a half. N is 3, it's a third. So it's almost like I'm marching along this headed towards 0, right? Like this. So I'm plugging in positive numbers. And the output, all the outputs of this whole thing are above the x-axis. So they are a positive. What I did in my 9 a.m. class is I said, hey, signs oscillate. You know what? Let's attack this with a different method later, and we just put it off to another method that we're going to cover. All right, so we could have actually done it earlier this morning. Sorry, guys. All right, so we're going to do it in here. All right, so they both are greater than 0. That one's obvious, right? Okay. And what do you want to show? Want to show that what's what? Yeah, this time the inequality is different. It's A sub n is bigger than B sub n. And that's because this one diverged, right? That's a divergent harmonic series, so the inequality is flipped. And, sine of 1 over n, is that bigger than or equal to 1 over n? Ooh. Ooh. Mm. Mm. What do you think? Any opinions here? Is sine of 1 over n bigger than 1 over n? You could do arc sine, but remember, if you do arc sine of this side, you're just going to get 1 over n, right? And if you do arc sine of this side, you're going to get arc sine of 1 over n. And I'm not quite sure that makes your life any better because you've trapped the n on this side also. So not necessarily getting us anywhere. I mean, we can multiply both sides by n. If it were just this, I would be able to draw a conclusion because I know that sine is always less than or equal to 1, right? So at least I'd have some idea of what's happening here. But the n is growing, right? So this is growing, and you're saying, oh, well, if this grows, then, and this must be between -1 and 1, then it's got to be bigger than 1? No, because what if this gets really small? Then this number is getting big, big times small, indeterminate form. This is a disaster, right? Do you understand this is a disaster? I mean, like, we cannot just look at that easily and tell. Well, I don't want to throw out the comparison that we chose because it said it's going to work. But what I'm going to do is I'm going to bring in the limit comparison instead of the comparison. Instead of the standard comparison, I'm going to do the part 3, which is the limit comparison. We have not used this, have we? And now I'm going to break it out. I want to show, okay, what I want to show here is that the limit as n goes to infinity of a sub n over b sub n. What do I need that to do? Go to some positive constant. That's what I want. So let's look at the limit as n goes to infinity of sine of 1 over n over 1 over n, right? And what happens if n goes to infinity? You get 0 over 0. And what happens when you see 0 over 0? L'Hopital, right? Let's try L'Hopital on this. Do you remember when I first told you about sequences and I said we can use L'Hopital as long as we convert the sequence over to a real function of x and then convert it back? But I said at some point I'm going to stop doing that. Like that's now happening. I'm doing L'Hopital. We understand that we're converting this to a function of x and coming back and all right, it's just we don't have the time to be writing it all down. So what is the derivative of the top? Cosine of 1 over n, chain rule. Oh, that's antiderivative, careful. This is the same as n to the negative 1, right? Derivative of n to the negative 1, negative 1 over n squared, right? Derivative n to the negative 1 is negative 1, n to the negative 2, which is this, over derivative negative 1 over n squared, right? It's very common. You forget if you're walking forward or backwards sometimes, right? So we are going back to Cal 1 derivatives. Cancel these out. That's a nice thing that those canceled. And now let n go to infinity. 1 over infinity approaches 0. Cosine of 0 is 1. And that is a positive constant. And therefore, what? Whatever they do, they both do, right? And I know what one of them does, so that one has to do the same thing. So this diverges. So we were not able to show it diverged using this same one, right? Using this, but trying to do part 2, where we were messing with the inequality, we couldn't show the divergence. But using the limit comparison, part 3, we were able to show the divergence pretty easily, right? Okay. All right, let's try this one. Let's go 1 over 5 to the n plus 4. I sent an email out earlier today with the homework assignments for 8, 2, and 3, just so you could have them. I forgot to do it last time. Nobody emailed me about it, though, so I'm guessing you were busy doing other stuff. All right, so you look at this. What are you thinking here? Almost. Careful, not p. Remember, the n's in the exponent. It's the other way. Geometric, yeah. It looks pretty darn close to geometric, right? Like if that 4 wasn't there, geometric. So now I've already run through the nth term test in my head, right? I let n go to infinity, that thing went to 0. I'm already seeing geometric. I want to compare it to geometric. So I'm going to go right for the comparison right now. Let's go 1 over 5 to the n. I know that's geometric. And I know that it's going to converge, right? Because r is 1/5. I'm not writing that as 1/5 to the n, but convergent geometric series. And so I have my choice now. I can do the inequality, or I can do the limit comparison. So let's try the inequality first. What would I want to show? A sub n less than or equal to b sub n, right? So 1 over 5 to the n plus 4 is greater than or equal to 1 over 5 to the n, right? You agree? Is this true? Cross multiply. 5 to the n less than or equal to 5 to the n plus 4, right? I don't know why I put plus 4 up there. It needs to be out here. Subtract 5 to the n on both sides. 0 is less than or equal to 4. Done. Okay? Very, very straightforward. No issues. Conclusion? That converges. Why would I give you that example then? It's too easy, right? Too straightforward? All right, here's why. I want you to change the problem. I want you to make that a minus 4. Okay? We're going to redo the problem. We're going to do minus 4 instead. All right? So if I do minus 4 instead of plus 4, then I can still compare it to this, right? Right? Still geometric. It looks pretty darn close to geometric. Over here, I still need the same inequality, right? But this is now going to be minus 4, right? And then when I cross multiply, this is going to be minus 4. And uh-oh, I'm going to get 0 is less than or equal to negative 4. And that is not true. So what does that mean? The what?